Okay, so let us start with the first sum for today. Let me share my screen first. So I hope you can see the question on the screen. Are you able to see the question?
Yes, sir.
Okay, I'm giving you 5 minutes time to solve it. So I would ask you after 5 minutes what is the answer that you are getting. So what you need to do is you need to find the eigenvalue of this system matrix that has been given to you, and then you need to find out the ratio of the absolute value of the eigenvalues, minimum to maximum. Ratio of maximum eigenvalue to minimum eigenvalue, and when I'm talking about maximum minimum, I'm talking about the absolute value. Okay, the minimum maximum value of the absolute value of the eigenvalues. Okay, so try to do this sum. This question may not be that much relevant as per gate scenario right now, because you are not allowed to use calculators. You would be getting some third order equation, cubic equation to solve. So anyways, just try it out and then we will discuss. So 5 minutes are up. How many of you have got the answers? Anybody with the answer yet?
Uh, no, sir, I'm solving for that cubic equation to get lambda value.
Okay. Anybody else? Okay, then let me discuss the solution. Okay, this much you know, right? How to find the characteristic equation of the system. Hello?
Yes, sir.
This equation you know, right? How to find the characteristic equation of the system of a matrix. Okay, so if you find the determinant of lambda I minus a, where lambda is the eigenvalue in this case, so you can write the equation like this. So lambda I is the identity matrix, and so lambda I minus a would be the matrix that I have written over here. So if you find this equation, so this is how you solve for the equation: lambda into this matrix, lambda plus 11 divided by 11 minus 6 lambda minus 5. So this matrix, then minus of minus 1, that is plus 1. You close this 2, and then this matrix 6 minus 6 6 lambda minus 5. Then you close this column and this row, you get 6 lambda plus 11, 6 and 11. So if you solve for this equation, you get a cubic equation like this: lambda cube plus 6 lambda square plus 10 lambda plus 6 equal to 0. Now it is difficult to solve it without a calculator. So if you do that, you get minus 3.77 and minus 1.11 plus minus 0.589 j. Now we are concerned only with the absolute value of the eigenvalues. So it would be the root over of magnitude of this root over of minus 1.11 square plus 0.589 whole square. So you get 1.256. And there is another eigenvalue which is minus 3.77. As I have told you, you need to consider only the absolute value, so 3.77. So you take the ratio of maximum by minimum, you will get around 3. So which of these two values, so you know what eigenvalues are? Are these the poles of the system? Can anybody tell? So can we say that the eigenvalues are the poles of the system?
Yes, sir.
Okay. So which of these poles are dominant?
Sir, minus 1.11.
Correct, correct. Yes. Why is it so?
Sir, because it's near the origin and at left hand side.
Okay, so what happens if it is near the origin? Why this is also, I mean, this is not too far from the origin. So why are you saying that this is dominant?
Sir, because of the time period.
Yes. So how which term of these two determines the time period? Now the time period, time constant, you can say.
Yes, sir.
Yeah.
So minus 1.11.
Yeah. Right. We have discussed about this in the previous session, right?
Yes, so that it will take less time to discharge or more time to discharge according
Decay.
to
It
that.
will. I mean, it
Decay,
would.
yes, sir.
Yeah, it would take more time to decay. 1.11. So it is more significant. This part is more significant. One which decays fast is not that significant because its effect would go rapidly go away. However, for this term would be more dominant. However, you see the magnitude difference is not that high. So in that case, you cannot eliminate this kind of pool. So you cannot do an approximation by eliminating that. But however, we can just say that this is more dominant than this. Okay, so let us move to the
So
next.
what are
Yes,
like absolute values? I'm not able to get it. Like when will
absolute
be saying
value.
something?
What is the absolute value of a constant of a complex number? Magnitude of it, right?
Okay, sir.
Okay. So let us move to the next question then. It's also a very simple question. It will hardly take you 1 or 2 minutes to solve it. So This is another 2014 gate question. So a Carnot map has been given to you, and you need to find the which of these four circuits is going to give you the function which is defined by this Carnot map. So again, I'm going to give you 5 minutes time to solve, and after that, I would ask you for the answers. Whoever solves it, just unmute yourself and say that you have solved it.
Sir, C.
Yeah, you are correct. C is the correct answer. Okay, so let us discuss. So you can see that you can form quads like this. Doublet. You can form doublets from the Carnot map that has been given to you, and based on this doublets that you have made, you can write the function a complement into c complement plus b into c. Why is it so? Because you see, as we move from here to here, the b is changing. However, a complement is a is still 0, so a complement. Okay, and look at c. C is also not changing. C is remaining at 0. So a complement into c complement. If we look at this doublet that is being formed, here c is again remaining constant, that is 1. So that is why I have written c. And then if we move from here to here, you see that the b variable is remaining constant, that is 1. However, the a is changing, so b into c. So if you look at this circuit that is being shown in option C, you will find that it is also giving the same function that has been given in the Carnot map. So these were the two questions that was given to me by NPTEL people for this week. So now I would ask you a few questions. Let us see. So you people are all from electrical background, right? Everyone is from electrical, yes or no? Can you just type in the window, chat window? Navkirti is from electrical. Okay. Okay. So you people have gone through power electronics? Okay. So I'm going to ask you a basic concept of power electronics. So how do you find the average voltage of a output voltage of a buck converter?
Sir, duty ratio into voltage.
How
In
do you find that? What is the relation that we use? What is the property that we use to find that, to come to that result?
so input power is equal to what?
Other than that, Have you heard anything of like voltage second balance?
Yes, sir.
So what is voltage second balance, and is it necessary to have a voltage second balance?
So average voltage zero,
Across whom is the average voltage zero?
inductor.
So what does that actually imply?
Whatever energy is stored, it will be discharged.
Discharge where?
So to the load.
Okay. So can we say anything about the flux in the inductor? So when you are doing voltage second balance, what exactly are you doing? So if the voltage waveform is like a square wave that you can see in the first waveform, what would be the flux waveform be like? Will it be triangular like this, like the red line that I've shown? Anybody in the class?
So as we apply voltage, flux will increase. So yes, this might be.
So what is the relation between the voltage induced and the flux?
So if voltage is induced, current will flow. As current increases, flux
What is
will
the relation of a
increase.
voltage and flux? What is the relationship between voltage and flux? What is the mathematical equation relating these two? Yes, Navkirti?
So relate. So 1 minute, I forgot.
Proportional.
Proportional to what? What
Basically, V
is
equal to L di by dt. So where L is N phi by I.
what is Faraday's law? What does Faraday's law says? When you say L di by dt, there you are making an assumption that inductance is constant. Is it always constant inductance? What do you
No,
think?
no, no.
When will it change?
When phi vary, then L change.
Sine omega t.
Sine omega t what?
So
Sir,
like
E equal to N d phi by dt.
Correct, correct, absolutely. V equal to N d phi by dt, right? So you can see it from the waveform itself. You can see the voltage is remaining constant, and what is constant in this waveform? That is the slope, right? The slope is constant. So it is V equal to N d psi dt, where psi is flux linkage. Okay, where psi is flux linkage. What happens if the volt second balance is not met? If that condition is not met, what happens? Any idea what happens?
Unbalance of energy.
Unbalance of
Means
energy.
charge
These are
means that much charging and
don't
not too much discharging.
don't bring in charge and all these things over here, because can you
Hmm.
form a mathematical equation out of it? You cannot form a mathematical equation. Say in terms of mathematics. How can you
Okay.
mathematically say it? I have already drawn the waveform. You can see the waveform and you can just say what I am doing over here.
So flux will increasing and voltage constant, and then flux decreasing, so voltage it suddenly goes down.
No, no, so look at the flux waveform and the voltage waveform. This is the voltage that you are applying. Okay, you are
Yes.
applying this voltage. Okay, so
Okay.
what are you saying going down? See, the problem is, so what actually you need to do is the flux must, I mean, the net change in flux over one cycle should be zero. So if the
Yes.
flux was here at time t equal to say t1, after t equal to t1 plus t, the flux should come down to this point. Or else what would happen is in the next cycle, you see the volt second balance is not met in the second waveform. What would happen is it is starting from this point t1, it is rising up to this point, falling down, but it has not come down till the point that it should come down. It has not come down to that point. Now, when I'm applying a plus V again in the next cycle, in the next half cycle, then it would actually go above what it was in the previous half cycle, right? This much, do you agree?
Yes, sir.
Now, after every cycle, this flux will keep on building in the core of the inductor, correct?
Yes, sir.
Do you agree with me? Whoever was speaking back then was talking about energy. Who was that? Who was the person talking about energy? I
No, no.
couldn't.
If
Uh,
where in sir in your diagram, if flux wave is periodic, then average value of voltage will always goes to zero. Means like you said, if I have a voltage flux at this time this much, and after some time, certain time period after flux again at this much, means flux is periodic, then voltage average value always get zero, average value of voltage.
no, no. What I am saying is, so you are talking about the first waveform. I'm talking about the second waveform. If you look at the second waveform, you see. If you look at the second waveform,
Hmm.
you see that if say I am applying 5 volt.
Okay.
Okay, 5 volt I'm applying. So the slope of this may be 5. It goes up to, say it is going up to uh, 1, say suppose some unit, 1 unit, say. Okay, yes or no? Okay, so this
Yes, sir.
was, so this was say, this was suppose -1 unit. Okay, so it has gone from -1 to 1. Okay, but it didn't have much time to go down. Okay, so say it has gone up to minus 0.5, 0.5. Okay,
Yes.
so now again it has to rise up to 2. So what is the peak now?
No, it more than two.
More than 2, of course. It's more than 1. Okay, so it is going.
Yes.
So what I'm saying is the net rise would be 2. From here to here, from this point to this point, it was 2. So from this point to this point, it will also be 2, because you are applying the
1.5.
constant voltage. You are applying constant voltage, right? This
Yes.
will, this will dictate your slope.
Yes. Yes.
The constant voltage would dictate your slope. So if this slope was 2 divided by whatever time period it was, in the next half cycle, the flux is going to rise above what it was before,
Yes.
right? In the
Yes.
next
Yes.
half cycle, it will go much above what it was before, right?
Yes.
So in after every half cycle, the flux peak is going to increase.
Yes.
So what happens if the flux keeps on building in a inductor core?
It will get heated.
Because it will get heated.
You see, if flux continues increasing, means the flux going to find infinite value.
Flux can go to infinite value in a transform in a inductor core. Can it practically go to infinite value,
No.
or will it saturate?
Saturate. Saturate.
So if it saturates, what will happen?
Mm,
Flux won't go above that value.
So what will happen?
Take maximum current. It will take any current will flow from inductor in
What would
saturation
happen?
period.
What would happen to the voltage induced across the inductor?
Okay.
What will happen to the voltage induced across the inductor? What I have just told is I had discussed, right? V equal to N d phi by dt. This you understood.
Yes, yes.
So if phi becomes constant now, what is the voltage across the inductor?
Wait,
Zero.
you have said phi become constant.
Phi has become constant.
So
So
differentiation of
voltage got
constant
zero.
zero.
Voltage will go to zero. That means it is acting as
Short circuit.
absolutely. So if you do not maintain this volt second balance, the inductor will be saturating and it will act as a short circuit. So that's why while deriving your input output voltage relation, you can see that all books they use this voltage second balance. Okay. A similar question maybe came in GATE 2020 or somewhat around that, in which a similar concept has been used. That's why I explained what actually happens. Why is this volt second balance necessary? Did you understand or still you have doubt?
Yes.
Got it, sir.
Is it clear to everybody?
Yes, sir.
Okay. So okay, I will end the session now because it is 7:39. We are done with today's discussion. Maybe next week we will be meeting again. Okay. So bye bye. Enjoy yourself.
Thank you, sir.